Number 19 on the 2.8 worksheet is asking you guys, is there a number whose cosine is equal to its opposite? Okay, so step number one on an intermediate value theorem problem, where they're just asking you to define, is there a number that does this or not, is to make an equation out of this. Is there a number whose cosine, so that is just going to be the cosine of some number x right there, is equal to its opposite, okay? That number right over there. And real quick, guys, I haven't really talked about this very much. Pretty darn sure the answer is yes, and here's why. If you were to just draw yourself a really quick graph of what this thing would look like, if you graph the left side, cosine of x, you guys know that roughly that's a function that looks something like this, don't really care about the details right now, and then you were to graph the right side, y equals negative x, it's going to be pretty darn clear that these two functions are definitely going to intersect at a point that looks like maybe right about there somewhere. But anyway, we can get into that a little bit later. That doesn't actually prove anything, and the intermediate value theorem will. Okay, so step one was to make the equation. Step two, let's get everything to one side and set it equal to 0. So I'm going to bring that negative x over to the right, so it's going to be cosine of x plus x is equal to 0. I want to know if there's a solution to that equation. So I'm going to call that f of x, and then I'm going to go ahead and make a table of values right here, x and f of x. And actually, I drew that graph a moment ago just for fun, but it does kind of tell me that it looks like there's a solution, and it looks like that solution occurs right here for a negative value of x. If I were to test 1 or 2 or 3 or 7 or anything like that, I'm not really sure that these graphs are ever going to intersect. So the graph actually might help me save some time by not bothering to test what I would normally test, 0, 1, 2, 3, 4, and look for a sign change. I should probably start at 0 and then work my way left with some negative values. So let's see what happens when we put in a 0. This we should be able to do by hand. Cosine of 0 is 1, plus 0 is 1. Okay, that's loads of fun. Now, what I'm going to start to do is put in some negative numbers. And you'll notice here, let's take a look, guys. We're not really asked, oh, it did say between two consecutive integers. I'm reading my directions now that I wrote. Okay, so that means I better put in a negative 1 and see what happens. Now, you are not going to be asked to come up with the cosine of negative 1 radian by hand, everybody. That's not going to happen. So we're going to need our calculator for that. So let's take a look here, everybody. We will go here. Oh boy, back to my home page. Oh, wait a minute. How do I do that here? Here? Yeah, there you go. All right, so let's redefine this function right here, guys. So I am going to, let's do this the easy way, maybe. Let me copy and paste all that, but just delete all the junk that I had there before, and here we go. We are going to do the cosine of x, close those parentheses here, and then we're just going to do a plus x at the end of all that, right? Right. And in your upper right-hand corner of your calculator screen, everybody, you should see the RAD typed. I've got mine kind of in my top left-hand corner here, just below where it says 1.1. So, good. We're in the right mode right there. And just to make sure we're doing all this right, we already did f1 of 0, and we came up with 1, which I believe is what we had. That's good. Now we want to go ahead and put in a negative 1 and see what happens there. So let's try that again here. f1 of negative 1, and you probably want to do Control-Enter to get a decimal. Perfect. That's what I was looking for, guys. We got a y value that's negative. I don't really care what the value is, but I'll write it down. Negative 0.460 is what happened when we put in negative 1. So negative 0.460, and sure enough, everybody, right here, your y value cannot jump from positive 1 to negative anything without equaling 0 at some c value in between 0 and negative 1. So I'm looking at what I was asking you guys to do on this right here. It said make a table of values showing a sign change between two consecutive integers and then answer the question. So our answer here would be yes, and our value here is going to be between, here we go, 0 and negative 1. And I probably should get in the habit of doing that from least to greatest, between negative 1 and 0. That's the interval now that we know this exists on. But now, let me go further with this. Use the bisection method to keep narrowing that down. Okay, so to do that, let me make my table a little bit bigger here, guys, and easier to see. So x and f of x. And we know, all right, here we go, that at 0 we got a value of 1, and at negative 1 we got a value of negative 0. I think it was 460, but it doesn't really matter. It's negative. Now we bisect that interval. Halfway between 0 and negative 1 is negative 0.5. So it's calculator time again. And let's evaluate here, got it, f1 of negative 0.5. Okay, and that ended up being positive 0.378. So let me write that down, 0.378. So now look at your three y values. Now we're looking for the sign change right here. Well, it doesn't occur up here on top. That's positive to positive. That's no good, but it does occur down here on the bottom. So somewhere now between negative 0.5 and negative 1, that's where our actual solution to this equation exists. So I will now bisect it again and go with negative 0.75 because that's halfway between negative 0.5 and negative 1. So let's try the same thing again now. And here we go. So we're going to do f1 of negative 0.75. And that gets us a negative result again, but just barely, negative 0.018. All right, negative. There we go. Negative 0.018. So where are we now? The sign change now occurs right here between negative 0.5 and negative 0.75. So we're going to bisect that one more time. Use your calculator if you need the help here, guys, but that's going to be negative 0.625. That's negative 5/8. Let's see what happens when we plug that one in. All right, should be the last time we have to do this now. So here we go. F1 of negative 0.625. Gotcha. And that looks like it gets us a positive result of 0.186. All right, let's write that down. 0.186. So where are we, guys? The sign change looks like it occurs right here then, guys. It's a 0 value somewhere in between these two x values. So from least to greatest, we would say that this solution exists on the interval from negative 0.75, always the lesser value first, and then the greater value, negative 0.625. And that's our answer to this question here. Now, just for fun, guys, since we did all this work in the calculator anyway, you can actually kind of verify your answer real quickly here. If I were to add a page, and let's add a calculator page, all right, and that's not what I thought was going to happen. I wanted to add a graph page, I'm sorry. So let's try that again. Add a graph. There we go. All right, and if I hit my up arrow here, there's f1 of x, the function we just dealt with, which was this one right here. You guys can see pretty clearly this thing crosses the x-axis. It equals 0, and that's what we were looking for, at an x value that's where? Somewhere between 0 and negative 1, but it definitely looks closer to negative 1 to me. So let me see. You guys, if you hit your menu button, and then we did a trace, and then I'm going to do a graph trace right here. I'm not really sure how this works on my iPad, everybody, but can I just move I can. There you go. We get a 0 right there, and I think your calculator will kind of lock on that 0 as well. So if you look in my lower right-hand corner, this is telling me that the actual solution to this equation is negative 0.739. Let's take a look at where we thought it was. Somewhere on this interval right here. So if the real solution was negative 0.739, you just want to make sure that this value is somewhere inside this interval here, and in fact it is. So that makes me feel even better about the answer that we came up with here for problem number 19.